A solar storm is hurtling toward the Earth after a powerful solar flare shot out from the Sun. Solar storms start with a huge explosion on the Sun. These explosions, called solar flares, can be about as powerful as billions of nuclear bombs. The Sun will reach the peak of its current activity cycle 1 year earlier than previous estimates, according to experts at NOAA's Space Weather Prediction Center. Predictions on when solar maximum will occur are based on long-term historical records of sunspot numbers, advanced statistics, and models of the solar dynamo, the flow of hot, ionized gases within the Sun that generate our star's magnetic field, which in turn drives the solar cycle. When a solar storm strikes the Earth, it often produces a dazzling, northern lights display in parts of the atmosphere that can be seen in areas close to the Arctic Circle. Solar storms can disrupt satellite operations, communication signals, and navigation systems. They can induce electrical currents in power lines, leading to power outages. For example, in February 2011, a CME produced by an especially powerful solar flare disrupted radio communications throughout China. Some experts believe a major solar storm could cause over 20 times the economic damage of the worst hurricane. During particularly strong space weather events, which are more common during solar maximum, Earth's magnetic field is disturbed and geomagnetic storms can penetrate the magnetosphere and lead to widespread radio and power blackouts, as well as endangering astronauts and Earth-orbiting satellites. One notable example occurred in 1989 when a CME accompanied a solar flare and plunged the entire province of Quebec, Canada, into an electrical blackout that lasted around 12 hours, according to NASA. Scientists who study solar storms have discovered that the frequency of solar flares appears to follow an 11-year solar cycle. At times of peak activity, there could be several solar storms each day. At other times, there might be less than one solar storm per week. Scientists expect the Sun's current activity cycle to result in a peak in solar storms. A solar storm is a term used for atmospheric effects felt on Earth from certain events that occur on the Sun. You probably think of the Sun as a bright shining light that never changes. In reality, it's an unbelievably huge ball of molten gases that's constantly in flux. Solar flares usually go hand in hand with the release of huge streams of charged plasma that travel at millions of miles per hour. These streams are called coronal mass ejections, or CMEs. When CMEs hit the Earth, they can cause geomagnetic storms. These phenomena send a stream of electrical charges and magnetic fields toward the Earth at a speed of about 3 million miles per hour. Types of solar storms. The Sun's magnetic field drives solar storms. Complex magnetic field interactions, often occurring near sunspots, lead to a sudden release of energy, causing these different types. Solar flares. Intense bursts of radiation are the Sun's most common type of solar storm. They emanate from the release of magnetic energy stored in the Sun's atmosphere and can last from minutes to hours. Coronal mass ejections, CMEs. Massive bursts of solar wind and magnetic fields rising above the solar corona or being released into space. CMEs can eject billions of tons of coronal material and carry an embedded magnetic field stronger than the background solar wind interplanetary magnetic field, IMF. Solar proton events. These involve large quantities of high-energy protons released by the Sun. These particles can reach Earth within minutes to hours of a major solar flare, posing a risk to astronauts and satellites. What are auroras? The interaction of solar storm particles with Earth's magnetic field and atmosphere creates spectacular light shows known as auroras. How an aurora is made. The process begins with the Sun emitting a stream of charged particles, known as the solar wind. As these particles approach Earth, they interact with the magnetic field that surrounds our planet. This magnetic field extends far into space and acts as a protective shield, deflecting many of the solar particles. However, near the polar regions, the Earth's magnetic field lines converge and guide these charged particles into the upper atmosphere. Here, they collide with oxygen and nitrogen atoms. These collisions excite the atoms, elevating electrons to higher energy levels. When these electrons return to their original energy levels, they release photons, small packets of light, which we see as the aurora. Auroras are best observed during the equinoxes due to the alignment of Earth's magnetic field with the solar wind. However, they can occur at any time and are more frequently seen in polar regions due to the structure of Earth's magnetic field. Auroras, often called northern or southern lights depending on their location, present one of nature's most spectacular displays. They occur when charged particles from the sun collide with Earth's magnetic field. This interaction energizes particles in Earth's atmosphere, causing them to light up and create the beautiful colors typical of auroras. Next solar storm that may hit Earth. The revised prediction now places Solar Cycle 25's peak of activity known as solar maximum between January and October 2024 according to a NOAA statement. The peak will be earlier, stronger and last longer than estimates made in 2019. On other hand, monitoring the sun's dipole magnetic field's rate of decrease, combined with sunspot observations, can predict the peak of an ongoing cycle. Their analysis suggests that the peak of Solar Cycle 25 is likely to occur in early 2024, with a range of uncertainty extending to September 2024. At times of peak activity, there could be several solar storms each day. At other times, there might be less than one solar storm per week. Scientists expect the sun's current activity cycle to result in a peak in solar storms during 2024 and also in 2025. Will these upcoming solar storms will impact Earth? Solar flares are internal reactions of the Sunday's solar mass ejections. Flares on the surface and other actions that result in the energy that dissipates from the sun in all directions, including the Earth and colliding with its magnetosphere. It provokes geomagnetic activity. They occur when the sun's magnetic field lines become stressed and break, resulting in massive explosions of energy from the sun. However, not all magnetosphere interferences are destructive, and one disturbance in particular gives rise to a remarkable light show called auroras. Minor geomagnetic storms are common, and medium ones come along every few years. Ones strong enough to damage the power grid or cause power outages happen every 10 to 20 years, but they largely only affect northern countries and only for a few hours. When this happens, our protective magnetic bubble known as the magnetosphere repels harmful energy away from Earth and traps it in zones called the Van Allen radiation belts. These donut-shaped belts of radiation can swell when the sun's activity increases. Luckily, thanks to the Earth's magnetosphere, ionosphere, and atmosphere, our planet is largely protected from the effects of these projections. However, they can still result in geomagnetic storms and power cuts.